Так, добрый вечер.
Good evening. Excuse the delay we had. We changed testing Postgres to actually changing the notebook. And Anton Necheukhin is going to tell us about testing of Postgres. 2, 3, mic check. Well, right now is going to be real hardcore because everything that was prepared beforehand right now is no longer prepared beforehand. And so I am in an identical situation with you because you have a computer. I also have a computer, which I am seeing for the first time in my life. And so our goal is to use this computer that I'm seeing for the first time in my life to launch our test and to see how are we able to test Postgres. And I think that I'm going to be trying to set this up on the go in order for us to be able to receive some sort of an end result by the end of this. And at the same time, I'm going to be talking to you, so please do not be alarmed by the fact that I'm talking and doing something with my hands at the same time. It is interesting what will come out of this because I have never tried this before. And the general idea, the main idea, 1 second, I'm just going to launch something, and you know what? That you can be doing the same thing as I am. Well, the password, okay, the password to GitHub, oh, I hope it's going to actually show the characters when I'm typing the password here. By the way, it's a good question. What is your password? I like it. And now we're also going to test my memory, see if I can remember this. Device verification code, what is this? So I have to go to my email now? Oh, God. So, yeah, I already found my email, yeah. This was, well, they're good, see, they're concerned with security, I like it. Good guys. And my repositories, no. Do we have a mouse? Does this weird computer have a mouse? Because its touchpad is not very comfortable. Now, and we are almost ready to start. And this is the presentation. And I think that we are going to start with it. So, the main idea is in the fact that we want to test our Postgres. And I'm going to tell you about what it means. And later you're going to find out what Marusi is and why everything has a strike through it. And you people have not yet gone through this link, then do it. The internet's fairly slow, so you can do the get pull and start it. And the repository is very small. I try to make it as minimalistic as possible so that there's nothing extra. I work in the mirroring company, and just in 2 words, I'm going to briefly speak about what product this is, because we are creating a product. Why? Because out of this, you'll be able to understand the context and why we have arrived at running these sort of tests, and in what cases this tool can be useful. Now, what do? We create a virtual online table whiteboard to which an infinite amount of users come to. So this is a tool for distance work of dispersed teams. And they can log on at the same time and do some brainstorms, draw different things, create widgets together, and so on and so forth. And an important detail, why have we arrived at testing Postgres? And these are usually overload tests. And right now we have approximately 26,000 users who are online. And all these data that are stored all over the widgets and everything else is all stored in Postgres. And the schema of our service looks approximately like this. I'm not going to go into details what is where, but the main part is that we have Postgres, and we have an important detail. Until very recently, we had the DDS database, and we're currently migrating from it to Postgres, and we're working with Postgres fairly recently, maybe 2.5 years. 2.5 years ago. This is the time when the migration started. and we are setting the Postgres up, we're tuning it, we're spreading out across shards, and we're doing a lot of technical setups that we would like to first test prior to actually launching them into action. Now, what do we want to test in the context of a database? What can you test? What do we mean by testing Postgres in our case? So, for example, testing difficult queries. No, heavy-end queries. I don't think so. I think because we can send the queries one way, do it according to plan, and check some optimization. So how does that look like? We launch a test. Well, generally, we look at the way our Postgres works and the instance which has the database running. And during the test, we can see that our CPU is continuously growing, and we are going through some stable load. So we did not account for this. Now, why can this be the case? We look into vlogs of Postgres, and we look that, for example, out of vacuum has not been launched a single time. And according to the way that we thought everything was going to go, and it's clear that the intensity of our workload with the data is inconsistent with the settings of our Postgres. And thereby, we are able to supply the load and to see how the database reacts. And then later, we're trying to investigate to find out what are the problematic areas. Now, the second case, so for example, we run a test and we see the checkpointer runs not nicely how it's meant to be on the left graph with the green ones, but we see it chaotically like it is on the left one. And what does this mean? This means that most probably the checkpoint is unable to work according to the schedule that we want it to work, and it means that most probably we're going to have a bunch of loot building up, and Postgres is going to try and deal with this log, and this is going to lead to our database slowing down at the end of the day. And in order to work with the loads in Postgres, I'm pretty sure you guys know there are utilities that allow to create this load. So PG replay allows us to play through everything that has been happening according to the logs. And how does this standard process of testing with Postgres tools look like? We take the dump of the databases on which we want to run these tests. And then inside the config menus, we turn on the full recording of all the actions that are being undertaken into a separate log, and then with the help of the PG replay, we're able to run this in the exact way as it has been done in real life. And of course, you have a bunch of parameters that allow us to fast forward the process, to slow down the process, and so on and so forth. And of course, if you've seen last year on this conference, the Postgres people have announced the instrument Nancy CLI. Please raise your hands if you used it. Okay, we see a number of hands in the audience. It means you used it, Nancy CLI. And so after this presentation, so we started thinking about the fact that it would not be too bad if we could use these sort of tests. And therefore, what is Nancy CLI? So Nancy CLI is a bar script which is 1,000 lines long, which can raise instances in Docker machines and can turn on the databases. So it raises this instance with PG replay. It launches the script with PG Pager. It replays the entire thing, and then we have an HTML log of what happened, an HTML report. And then we can change the parameters. So for example, we can change them in Postgres.Conf. And we can then compare these two launches. Everything is very quick, very comfortable, and so on and so forth. But when we started using it, there were a number of things that we didn't find there that we needed. Now, I'm going to speak in a bit more detail about this approach. The main idea is that we take a dump and then we record logs. Now, where do we take the logs from? Now, the most beautiful approach, it would seem, would be that during the production you would minimize the dump, record the user activity, so our real users, the ones who are actually using. And this seems that this is the most ideal load, is the actual recording of what the users do. But in real life, there are a number of issues with this. So in our case, we cannot use the production data in order to test, because we have issues with logs because there is a huge amount of information when a huge amount of users are working at the same time, and to try and overload the production capacities would not be a very good idea. But the main part is that we can record the point when there will be no issues. So, for example, we have obtained a statistically incorrect period of time when the users were not doing anything out of the ordinary, but in the test we want to take into account some nuances that is going to overload our database in non-standard ways. So, for example, some rises in usage, and therefore our solution is in that we are using our normal load tests. We have load tests with the use of spike tests, the use that showed the limits of our service, and right now we have 26,000. In a year and a half, we only had 12,000 people. And therefore, we are forecasting that we're going to have 50,000 and 100,000, and our application is built very complexly, and I'm sure that all of your applications are complexly. And when the load increases, it's not always possible to fully predict what the bottleneck in the service is going to be. And in order for you to have a 100% chance of forecasting where is that place going to be, is to replicate the load that you're going to experience with 100,000 users, and just to see what crashes first. And that's what we do. So our load test is created based on the analytics and is trying to replicate not only the realistic load that the users create, but also some non-standard situations, some increases and spikes. And what we try to do is replicate is the intensity that we use to work with the database, is the intensity of transactions, is how we read the databases, is the non-normalized work, because when the load is not spread out, it's very different. And the database, that is the data inside, is not just garbage data. This is the data that we generate with our API that uses client in order to create widgets, whiteboards, and so on. So these are realistic data that we prepare in the form of the proportions that they look like in real life. So we try to analyze how it looks in general and try to replicate it. And from the analytics, we're able to get this profile of load. So what I'm trying to say is that we're not trying to look at how our servers look like right now and to replicate that, but we're trying to replicate the profile loads using the actions that our users use. So I think that during this presentation, I think there are two articles that describe in detail how we conduct the load tests in general. Right now, I'm not going to touch on the subject because this is only a source of the scenario itself, and is only the source for the logs of replays. And later you will be able to read up on this in more detail because these articles cover it deeply. Therefore, now, how within this scenario you have separate blocks that are responsible for the load of, for example, this block is responsible for creating a spike, this block creates the stable load, this creates another spike, and in order for us to create the load profile that we need, we have the appropriate blocks that allow us to compile this profile. And now we're going to move to Marusi. And this is why it's called Marusia, because last time it was called Nancy, and they sound somewhat alike. And now what were we missing? We were missing flexibility. So we wanted to launch tests and see what we want to see, meaning that we wanted to use our own monitoring in order to analyze the results. The monitoring, the same as we use on production with the huge amount of tags and so on. This is the most important. The second part that we were missing, that we wanted to see there, is that because this is a load test, we wanted to see infrastructure that would be very similar to the infrastructure of production, so that our database is not going to be in Docker, so that we would be able to launch this on a number of devices at the same time. And generally, the configuration of the databases is most frequently, well, this is not a single database where something happens outside any context. Usually there is a cluster or a more complicated structure, and we want to replicate it just as easily. And so we ended up with this tool, and I'm going to cover this in detail right now. I'm going to show you how does it look like, how does it work, and I hope that we will be successful. The main idea is that when I was using Nancy and I was trying to make it work better, and I was trying to finish this script so it would not just be a support, but so that it would be an actual, so that it could have functional, something your script could carry out before it carries out what it meant to be. So, for example, you would use the node exporter or the Postgres exporter and some other things that are just necessary in order for our monitoring to actually work. And I thought that this was a bit too complex and very hard to set up. So at one point in time, I understood that it would be easier to just leave it be and to create the same thing, but using more what I see as more comfortable tools, but which are more popular right now and which are designed especially for this. And so this part, which creates instances, I have switched it all to Terraform and everything that configures to ASIC. So we're using the same Gary Play and so forth in order to launch this comfortably and to, for example, switch configurations and so on. And in this schema, you also had a VPN. And right now, the version of it that you see on GitHub, there is no VPN. That's because of two details. On one hand, it's a tool for testing your database, and like, why are we talking about VPC and VPN? But we do use this in our work, because even the test data is something we don't want to get out, so we have only secure access to the data only of certain authorized person surroundings. And so now in this demonstration version of Marusia, all this is absent. And now the second case is the instance that is created with this tool is the DB tool, which has these tools like the GB tools, which you can use, and which has a node exporter in order to see that this instance that it currently creates, the load, does not itself crash. And there's a third instance where we have the Postgres and the testing database where it's launched, and the exporter to understand how it all looks like. And the monitoring, in our case, is, well, you can just make it look how you want it to look. You don't have to use our version. And right now there is no PG Badger, but we understood it's best to bring it back because it brings the capacity to get a lot of interesting results and just easier to analyze. And so the launch itself looks very simply. It looks like and these are two examples. The first one launches with the speed twice as fast, and the second one launches as fast as it can, ping being the limit. And the idea here is that right now we are able to configure any infrastructure. We no longer need to recreate them from test to test. So we created this once, and at the end of the day, we can just kill it. And well, yeah, that's about it. And right now, I suggest that we just have a look at this so that we can see how it looks like in action in real life. Here you can see the tool itself. Now, are there people who would like to actually try and do this right now? I see one person. One person, that's it? Oh. Okay, come on, try. Come. Oh yeah, by the way, let's ask questions while we're going, because if we get too far away, it'll be too hard. Okay, two questions. One is, you're testing a platform and a device platform, so you're an apparatus platform where you're going to see a new shard being launched, or the cloud platform, or are you testing the profile of load on the shard itself to just check how much the shard can fully tolerate? No, this is probably not about the maximum load. This is more because we're trying to replicate the intensity that we currently have, or the intensity that we are going to have tomorrow. So it's not a testing for stress. It's some more realistic. It's a more realistic condition. And so the configuration of the database and the structure of the data inside the database, we just want to make sure that they work correctly when the intensity of the workload on the database is increased. So you see the results and you understand that, A, you are fine with the platform, the API platform works fine, where you are running the instance. And second is that all your configurations of your DCMS works, and does the size of the shard is the size of the shard limited by the amount of clients or maybe by the internal logic? Well, logically, yeah, we have our own limits that we set up for ourselves, and we do it by conducting the same sort of tests. So, for example, we could have a database of 400 gigabytes or 1 terabyte and then launch tests and see how much data fits on to the memory there. And is the amount of random application memory sufficient for this in order for it to function well? Well, I had a very similar task at hand. Now, if it's not too hard, can you please give me an example of how big is the database and the minimal configuration for this? So what have you arrived at the end of the day? To which configurations? Yes, I can give these examples generally, but I think that this is information that is hardly applicable in non-specific scenarios, because up here a lot depends on the data itself and on everything else, all the other details. So I don't know if there's a point to it. Maybe there are more questions. Yes, come on, please. Yes, now you can hear me. Great. Good day. Hello. Well, it seems that you left out the fact that your application is not actively taking part in this testing because you're not directly inputting this with insets and recording the database. Right? So we can analyze the load profile of your application as well. And this is one more aspect of the task at hand. Am I correct in understanding this? Or is everything going to shift to Postgres, if I get it? If I understand your question correctly, you're trying to ask that this tool allows us to test only the infrastructure that is connected with Postgres. And yes, naturally, of course, we need for the load, in real life, the load that is created can also put something else out of order. But for this, we have other load tests, the links to which I have displayed before. But this particular test is designed only for testing the infrastructure. Yes, thank you very much, just as well as I understood it. Thank you. Yes, there was one more question there in the back. Anton, I have a question. So the tuning of Postgres is a very risky endeavor because, for example, everything works fine on 100 gigs, but on 500 gigs it just stops functioning. So do you test this on the current dumps? And if you test on larger ones, yes, we do test it on current dumps, and we do this fairly rarely. And how much larger do we get them? Well, usually we make it double. Sometimes we make it twice bigger, sometimes more. Right now, well, how does it look like? Right now we are prepared. For us, it's better to have more shards and to go on with a stable life. Maybe they will be smaller, but I know that they're definitely going to be functioning well. And at the same time, we know that if they are going to increase twice-fold, then with the same load profile, they're still going to function stably. So we're not going deep into analysis what exactly can go wrong. And the main reason for this is, as I've already said earlier, because we are currently migrating to Postgres, and the fact that not only us, but it is important that we ourselves are also significantly changing the profile, the load profile. So to study ourselves, to study how exactly our database is going to behave in 2 years, and right now it's not plausible because we're going to change the profile of load within half a year. Now, let us try to move forward. It's interesting. Okay, let's see. How is all this going to look like here? Well, here we have the depository. And the most interesting part here, I think, is to try and conduct this live. But how can we copy? Control-Shift-V. Control-Shift-V, I know this. Well, the touchpad doesn't have a middle mouse button. The right one doesn't work either on the touchpad. Nothing works. It's just amazing. And what are you going to tell me, that we have to type this up manually? Oh, we're not going to get far if you're going to do it this way. Shift, insert, Shift, FN, insert. That doesn't work either. No. Oh boy. Oh, okay. So that's how you can do it. Okay. Yeah, success. Thank you very much. Can you see what is being displayed? I wonder if there's a way to scale this, to increase it. Can you people see what's written up there? Oh, well, if you're using a MacBook, you can just do this just with two buttons. But with Windows, I haven't worked with it for the past maybe 4 years. Here in your Windows settings, you have, oh my God, JSON, oh God. Well, okay, while we're getting this sorted, I'm going to continue talking. Well, we have one person who is bravely trying to replicate what we're doing, and I hope that you will succeed faster than I will over here. How much did we just have? No, we can keep it at 16, 18 is fine. Nah, I think not. I think we'll have to restart it. Well, something evidently went wrong. So what can we do? How can we show this to you? Okay, let me just continue answering questions while we're trying to sort this out. How can we calculate an abstract user? Well, because you get different questions every time, you get different user load at different times, and it's very hard to forecast what exact queries are going to come in. How are you able to find the mean or the median of this? How you get the average? Well, we don't try to get the average, we try to get some sort of user profiles. And for example, we understand that a part of profiles work with small whiteboards, and there's this many. And the part work with large boards, and there are this many of those. And part of the users actively create content, and a part of the users are only viewing it. And so, by collecting this information, by getting these proportions together, we're able to create this load profile. Okay. Okay. Oh, now this is looking good. And what can we do now? In order for all of this to work, we have to use Terraform, and I hope that there is a comfortable instruction here. And every step is described. And really, if you really want to, you can just follow the instructions, and you have my contacts there. And at any point in time, you can ask me questions in order for, well, in case something goes wrong. And the saddest part is that we will have to download a huge amount of utilities, and the very first thing we need is Ansible. Now, who worked with Ansible? Please raise your hand. Wow, there's many of you. So I don't have to talk about this at all. I just need to download it. Where is my Ubuntu? No, okay, everything is simple, right? And let's see how well this is going to go. Okay, there we go. That's going to be quick, and we'll need Terraform as well. And the most difficult part when you're preparing, when I was preparing for this masterclass, because I had to prepare a profile in Amazon, because the confirmation from Amazon, if you haven't done this beforehand, nothing would have worked out. Now, in order for all of this, okay, while this is happening, let me get the fix missing. Yeah, I thought that I had to do this. Yes, okay, let's. And the last one now. Well, it definitely works in the latest version, but I'm not sure about the version 2.7. And the same applies for Terraform. With Terraform, everything is way worse regarding this. I think you can only use the 12th version there, and that's it. Well, the main idea is that it's all written in the repository that everything is meant to work fairly quickly, and in order to create this from scratch, this entire cluster, and to actually run the test, so for the creation and the running of the test, when the internet works fine, it takes 8 minutes. So everything works, actually, I see it's working fairly fine, so we have all the chances that we'll actually manage to get it done. And even taking into consideration the fact that instances in Amazon are very expensive and they can be somewhat complex, this can be created for example, an hour and then kill it off, and it will be worth peanuts. So even if you use some sort of the third cell is doing without asking, I hope that you're fine with this computer, and I'll just leave it like this. And so I think that when you're using your own SJS, so you still have situations where you need to test something, and in order to purchase new hardware, you will need a lot of time. And so the time when the testing should have been tested, the time can be very fleeting, and you can use cloud services for this, because you're not going to be uploading any user data or anything else. So you will upload it quickly and then kill it, and you'll pay a maximum $2 for this, and everything will be great. And so now the second part. Yeah, I shouldn't have done that. The second part is Terraform, and I think it will install quicker, and everything should start up. Here we see a similar link. I think I can Google it quicker. And we are going to pick. I hope that we're on 64. No, that's not how it's done. Okay, fine. What if we try it this way? Okay, got unlucky there. Using this one. It's just going to download. And then we'll just have to use transfer it from Windows to Ubuntu, yeah? Okay.
Да. Да-да-да.
Great, thank you. Let's move forward. Do you have any more questions? Could you please show the Terraform while it's downloading? Yes, this is a good idea. Let's check it out. Correct. So what do we have here? It's very simple. Basically, can you see? We're saying that we will work with WES. We put the region. We indicate the operational system for these instances. We create our key. In the variable file, we indicate the SSH key. And accordingly, the resource will be created in the account of Amazon, and we will have the key to enter these instances. Then we're using the external module for CVPC configuration. So for secure access, we're using the external module and we put zeros. So we have access to the instances, and instances have access to internet. That's it. So we create such VPC which can do anything. So we have 3 blocks. DB instance, which will send the load. Here we put its type, the size of the disk, the instance where we will develop the database, and instance where we'll implement monitoring. And the IP addresses of these instances will be uploaded to the console. Actually, this is not my intention to give you the final solution. I just wanted to show you the approach. First of all, you don't have to use Amazon. You can use anything else. And this is configured rather easily. You're using the ready images of your instances, or you compile them during the installations. Yes, we are trying to avoid using the ready images because it's difficult to configure, so this is why we're trying to avoid it. Another important information which I would like to give to you is that we're trying to use approach infrastructure as code. This enables us to contribute to development of infrastructure. We can give our tool for testing, etc., etc., and everything that we do is written in our code. Let's see the final result. I need to install it to unpack it. Simply with zip. Typing the command. Now we unpack. Yes, the only thing which we need to do, we need to input the parameters. Here we can see that we have this file with the variables, and we need to indicate the key. We have only 30 minutes left, and I have doubts that we have enough time. So we encountered a problem. Now I need to somehow transfer them, and I have one solution in mind, but okay, in order not to waste time, I suggest to surrender, because within 29 minutes it's impossible to transfer the keys. I'm very sorry that it happened in this way. I can take another question and then move forward. Unfortunately, it was impossible to demonstrate the whole process. Let's maybe just to understand. So we use the hardware, install your program, we indicate the server, the database which we would like to test, and then we load it with your tests. And how can we calculate the resources of the system? If the system is weaker than the system where the database is installed, it will not be able to give enough load to see the actual capability of the database server. Yes, this is correct, and we have node exporter for the instance which gives the load, but it depends on your approach and on your case, on your database, your intensity, your scenario, etc. I will not be able to tell you how to choose for your particular case, but we have all the possibilities to achieve a certain intensity. And you will be able to see the instance with the database, how much it is loaded. So preliminary, we need to perform analysis of the two systems. Yes, of course. So now let's move on to the second part. We created, imagine that we created 4 instances in Amazon using Terraform. And accordingly, we will indicate these IP addresses. And this is the last manual action which we need to do. Unfortunately, it's impossible without magic, because the connection of Terraform is very complicated. So what do we have? We have this file with the whole sequence of configuration which we have. Here we can see the roles, the sequence, in order to configure all the instances which we have. Python, we need to be able to access these instances, Postgres must be installed to the instance. Base will configure everything for startup of the load. Restore will restore the data. In the database, it will deploy the temp. Exporters will be installed, and monitoring will be performed using this rule. Then you can check everything what's inside. I will show you because just to demonstrate that it's very simple, and you should use it for similar cases. For example, let's check the Postgres. We have a row. Where we have a configuration file. Which will install the password in this case, but actually we can indicate any changes after installation of Postgres. There is the installation itself, which is very simple. We add depository key and install from a certain version. And accordingly, main contains the whole sequence of actions. We need to install lots of Pythons, which we need to start the Postgres. We need to install system variables and the Postgres from the image, external image. That's it. I can show you briefly something else. For example, restore, which takes the file, copy it, and with the aim of restore utility, it restores it. There is no magic, it's a very simple configuration. Many of you worked with Sensible before. It can be done within one day in a way which you need, and then it can be used and restored by many others. We have dashboards. Unfortunately, I cannot show how it looks in reality, but the main idea is that it will be configured without our intervention. They will connect with each other, and it will be stored in a separate volume. And the dashboards, which we will need for analysis, will be uploaded as JSON. These are the basic dashboards for analysis, for node exporter, and for Postgres. You can deploy everything and to check how dashboard look. And everything will be started automatically. In order to restore the new dashboard, you need just to put the JSON file in the folder and everything will start automatically. You don't need to do anything. What else might be interesting? In the same way, exporters like Docker Compose will be able to install and start, etc. So everything is very simple. What would you like to hear in more detail? The results, unfortunately, we cannot get. You showed how Postgres is installed, but how it's configured. What parameters can be changed is not clear. Is it a box solution? So how we will test it in this case? As an example, this is Postgres template in default view. We can change certain parameters, And in the same way, we can replace all other configs. I can show you how it works. Here. No, not here. So these files will be simply copied. Maybe it's possible to install Postgres config for each type of, for each case. Yes, it's possible. This is just an example. Another question and continuation of the previous. How do you scale parameters depending on the virtual machine? You change the configuration file manually, or you can install Amazon instance template. I don't know if it exists. We scale manually, yes, in the configuration file. But you can look the CPU, the memory, and to calculate as per the formula. It's possible, but it depends highly on the profile of the load. For example, to increase the load 2 times is possible, but we do not perform this like this. We do it manually. Another question. In production, all your databases are installed in Amazon. So it's not tuned, for example, the core. Postgres default settings are normally not used, and more often the basic things can be changed. I mean, so in future we can use the results of the test to extrapolate. We need the instance the same as the product, or at least similar. Do you have the settings for Linux, for Postgres? Yes, when we create the instances here, the variables show us the type of instance. This is 2 micro, because for the presentation I was going to use the free account of Amazon. But we can use for this type of test exactly the same types of machine. For instance, we used the separate database for 1 hour service. We could evaluate the frequency of connections to the database. We knew how many connections, how many queries, let's say 10,000. And for this configuration, we compiled a certain infrastructure. This is one moment. Another one is that this is one point for the whole service, and we would like it to be very reliable. So it has replicas. We need at least 2 balances. And we created this whole system. We configured it. We used test to make sure that it works, and then we can use different utilities for house testing or something similar in order to understand how the system will behave in case of network interruption or slowdown, or master will end, how it will work, how it will switch to slave, and all the rest. And accordingly, this infrastructure is described in code and tested, and then production gets exactly the same code which we tested. Any more questions? Unfortunately, it's not a master class, it's a Q&A session instead. If possible, could you please explain how you analyze the results? At least the logic. If we're talking about the load test for the web server, there is a basic logic. We should look at response time, it should not increase. We should look at errors, at throughput constant. We look as a whole, then we look separately at each endpoint. So this is the basic logic. And what is the logic for your testing? I have a screenshot here. The problem is that it shows not exporter, unfortunately. Postgres dashboards in JSON will not be able to see, but in general, firstly, what we keep our attention at is the CPU and memory, which is logical and clear. If we're talking about using of memory, then of course we want our hot data to be stored in cache, to be read very quickly, and that's the most important probably. And the second important question is work with the drive, because our Postgres is tuned in a way so the data is dumped to disk fast enough. So auto vacuum would work properly. These are the two most important things which we tuned very actively, and accordingly this is the main necessity of such tests, because we need to look forward. We need to understand the intensity of dumping of data to disk, and we need to forecast this intensity, and this is the main case for such type of tests. And secondly is what I told you just now, to select the infrastructure and to understand the load of the CPU and other basic things are the most important, because we just need to understand the volume of instance with which number of cores, etc. The details are in JSON. They are shared, and you can see a lot of graphs. Load profile is just reading, or how you keep the consistency of data? And another question about the profile of load. You're saying that you're using it to forecast the load in case of increase of number of users. Do you double this dump of actions? And also, how do you keep consistency in this case? Well, firstly, about the keeping of consistency from start to start. If we have read, that was the idea of your question. I will repeat. Let's say you have dump of actions of users. Let's say 50,000 users created something simultaneously. How do you double them? That's the second question. And first question is how the data is created in your database, and how do you catch a moment where, in which condition the database has been at the beginning of writing, in the middle, in the end. This is not very clear, because the consistency and structure of data is important for the graphs. Actually, we think a lot about this question, and we're trying to prepare the testing data in the same way as our users work. And preparation of database is exactly like this. We take the test, which creates this data. As per the certain scenario, it creates data according to the proportions. And probably the behavior of this database will be different from production because it has a lot of things going on simultaneously. The second part is about the condition of the database. In order to perform the test, we need to warm up the database, because if we just restore the database, everything will be clean and the behavior will be completely different. So this is why we are using for different cases different approaches. We're trying to generate the load or something similar. This was the first question, and from start to start everything is recreated from the beginning. And the Nancy idea for the Postgres I/O recreated instances every time because we cannot use the same database. It's useless to store this instance. But we do not recreate the instance, we recreate a database which is a little bit faster. And the double offload. So what's important here is that everything we can do is the queries which has been distributed in time in a certain way. We can simply compress them, and this will create the doubling of load. And we can compress them only until the moment, let's say we have 2 seconds, we'll then compress it to 1 second and then to 0 seconds. And this is the maximum load which we can take from this scenario. And now during the writing of scenario, we're trying to write it faster than we actually need it, because it's easier to slow this scenario down than to speed it up, because there is a certain limit. A couple more questions. First, about the data for tests. You can take the data from prod and recreate the actual load. Yes, we can. We need to write scripts which will do this. So in the end, you will get a proof of security. Second question. We are testing AWS very actively in Google Cloud. And the question is, what storages you're using in AWS? For example, there is persistent storage, there is storage from Amazon. I cannot tell you from the top of my head. Maybe later we can exchange the contact details and I will look. We studied this, but I cannot tell you right away. I encountered that in order to get normal TPS, you need to have a database of 100 gigabytes in 0.5 terabytes section. Yes, I understand what you mean. We also had similar problem, just I do not remember the outcome. I will tell you later. We have 5 more minutes. Thank you for your presentation. I have 2 questions. First, how you compare the results? You overlap one graph with another or something else? And did you try to use dynamic inventory or tags, so you don't have to write the names manually? This is a very good question. First, in Nancy, we can see the difference, which is described with the basic tools. and you can get a very beautiful report to understand the behavior. Here you do not have this, and our comparison is like we can see one test, something happened, and then there will be another one, and we will look at them like this. In theory, we can try to create some comparative graphs. The field is quite extensive. For our purposes, this comparison is enough, but there is no limit and it can be developed further. This is an interesting subject. And tags, the same. I know about this story. Just we didn't reach this stage yet. Marussia is just a certain database, and then if you need, then you can develop it. There is no limit. The configuration is very convenient and comfortable. That's it. Thank you for such good questions.